All right, boys and girls, now we're starting with example 7, basically evaluating compositions of functions. And so the directions are simple. They just want you to find the exact value, okay? So you can actually do this one of two ways. You can do it algebraically or graphically, so using graphing utility, okay? So I'm going to do it algebraically because honestly, to me, it's pretty simple. And you're going to get an exact value. If you use the calculator or Desmos, you're going to get an approximation, okay? Oops. So let's get started. Okay, so you doing it algebraically. Okay, so you're not going to be able to use the composition because here we have tangent and here we're working with cosine, okay? Remember, whenever you have your inverse in here, you want to be looking at the domain, okay? So the domain is from -1 to 1. This will help us out, okay? So algebraically, I'm trying to get my markers accurate. Okay, so here we go. Okay, so my domain of our cosine is -1 to 1. Keep that in mind. But what we're going to do, since we're going to solve this algebraically, is we're going to write this as tangent of u. So basically what that means is that u is going to represent arc cosine of 2/3, okay? Or you can say this actually means the same as saying cosine. Oops. I'm actually trying to color code. Sorry, guys. Cosine of u should equal 2/3, okay? All right, so this is where we're at. We're just concentrating on the inside, okay? So again, let me just kind of reiterate. So tangent of u. So I just rewrote this where u is going to represent the inside. So u is going to represent arc cosine of 2/3. Remember, the inverse can be written as cosine of u equals 2/3, okay? So now going back to the domain. We know that the domain of cosine inverse goes from -1 to 1, or that the range basically goes from 0 to pi. Because our angle is going to be positive, then we're pretty much looking at quadrant 1. What that means is we're going to be drawing a triangle at quadrant 1. Okay, so this is our y, this is our x. So you're going to be drawing a triangle, so it looks like this. Okay, and then we're going to label it based on this. Okay, so cosine of u equals 2/3. Now, if you hopefully you remember your trig functions, but cosine is ca, or adjacent over hypotenuse, or cosine equals adjacent over hypotenuse. I should have wrote it that way. Okay, what that means is adjacent would be 2 and hypotenuse is 3. Okay, so how do we apply that to the triangle? So our angle u will be here. Okay, that refers to our angle, and then 2 is going to be here. This is the adjacent side. Hypotenuse will be 3, okay? And we are going to be solving for this side right here, okay? Okay, so hopefully I have enough room here. I might have to erase, but here we go. So if you have a right triangle, how do we solve for a missing side in a right triangle? We use the Pythagorean theorem. Okay, so the Pythagorean theorem, of course, is a squared plus b squared equals c squared. Okay, remember a and b are the legs and c is the hypotenuse. Okay, so basically we're going to solve for, in this case, I'll just go ahead and call it b. Okay, so we should have 2 squared plus b squared equals 3 squared. Okay. You guys, I'm going to do it a little bit faster just because you should be able to solve for this. Okay. So B should equal 9 minus 4, and we want the square root of that. Okay. So what's 9 minus 4? Square root of 5. Okay. I skipped a lot of steps that I'm able to do mental math. Again, this is a Pythagorean theorem. You've done Pythagorean theorem a while back, so you guys can just work it out yourselves, okay? And I did that in an effort to just save space. So the missing side should be square root of 5, okay? So now we know, okay, we know that inside here, u is the same as saying arc cosine of 2/3. And we know that cosine of u is 2/3. Okay? So here we go. Next step, I'm going to move my board. So if you recall, we have tangent of u. So now I'm going to use this triangle right here to help me find tangent of u. Okay? So maybe I should write it above. Okay. Tangent is TOA, or tangent equals opposite over adjacent. Okay. So tangent of u is, we're going to go over here, is opposite over adjacent. So this is your opposite, this is your adjacent, and this is your hypotenuse. So we should have square root of 5 over 2, okay? And this would be our final answer. Tangent of u is square root of 5 over 2. And that's it. And we were able to do this algebraically, okay? And this is our exact value. So in essence, you're pretty much just setting it up, okay, if that makes sense. We're not solving for u, okay? We're never solving for u, okay? We're just solving for tan. Remember, these will not cancel each other out because one's a tangent and one's an inverse, and they're not the same, okay? So we can't use those properties. When they ask us to find the exact value, we pretty much are finding like a ratio, okay? Just setting it up. So this is our final answer. Tangent of u is square root of 5 over 2. Okay, so square root of 5 over 2. And we don't want decimals. This is an exact answer. Okay. All right, hopefully you were able to follow me. If not, let's move on to another example. And I'm going to go ahead and wipe it all out, and hopefully I'll have more room. All right, so the next one that we're going to be doing is cosine of arc sine of -3 over 5. Sorry, that should be a 5. All right, there we go. That looks better. Okay, so again, because we're looking at our inverse inside, sine inverse is from -1 to 1. Or you can think of it this way. Our range goes from -pi over 2 to pi over 2. So pretty much what you're doing is you're looking at quadrant 1 and quadrant 4, okay? But because it's negative, we're pretty much going to be in quadrant 4, okay? And if you're wondering why quadrant 4, because remember, from 0 to -pi over 2, our value should be positive. And then if we work down this way, our value should be negative, okay? So this would be x, this would be y. Again, this is sine. Okay, so we're going to do the same thing. We're going to draw a triangle, okay? And then sine, remember sine is so, and what that means is sine equals opposite over hypotenuse. So our angle will be here, and I'm going to continue to call our angle u, okay? So just kind of to refresh your memory, I can write this as cosine u, okay? And u is going to represent arc sine of -3 over 5. Or remember, I can rewrite this as the sine of u, which is -3 over 5, okay? I'm pretty much using the inverse properties, okay, that we learned in day 1. So this is my angle right here. This is my angle of reference. And opposite of that would be here. That would be -3, okay? And again, just to refresh your memory, this is opposite. And then hypotenuse would be 5. So this would be 5, and that's the hypotenuse. What we're going to be solving for is the adjacent, okay? So now that we have this triangle, we're going to solve for the adjacent. And you know you need the adjacent because cosine is ca, which is adjacent over hypotenuse, okay? So once again, you're going to be using the Pythagorean theorem. So a squared plus b squared equals c squared, okay? Again, we should be technically able to go a little bit faster with this one. So a and b are my legs, so I'm just going to call little a the same for adjacent. Okay, so I'm just going to say a squared plus -3 squared equals 5 squared. Okay, and again, you can kind of connect the dots. You work it out, but I'm going to go ahead and just solve it. So a equals square root of 5 squared, which is 25, minus 9. And 25 minus 9 is 16, and we want the square root of 16, which is 4. So a equals 4. Okay, whoops, a equals 4. And that's our adjacent side, okay? So now that we found our adjacent side, I can come up here and just put it. This is 4. So awesome. So now we're going back to the very beginning. Cosine of u. So cosine of u, remember this is our u. This is our angle of reference. And again, just to remind you, cosine is ca, which is basically adjacent over hypotenuse. So our adjacent would be 4 and our hypotenuse would be 5. So this is 4 over 5. Okay. And that's it. Just 4 over 5. So this is our exact value. Sorry, I was out of frame. Okay, do I want to do one more with you? Okay, let's try one more. I am going to have you guys do the checkpoint, but let's try one more. Okay, so for this next example, I figured I'd try one with tangent. So, okay, here we go. So cosine of u, okay? U is going to represent inside my parentheses. So u will be arc tangent of -2/5, okay? And remember, I can rewrite any inverse function as tangent of u equals -2/5, okay? This is a property, okay? We learned that in day 1. Okay, so now I'm going to set up my triangle. So looking inside the parentheses, this helps me set up my triangle, okay? So arc tangent, my range goes from -pi/2 to pi/2. So pretty much I'm looking at my first and fourth quadrant, okay? Because it's negative, I'm going to draw it on my fourth quadrant. Okay, so should be much quicker now. So this is my x, this is my y, and again, here's my angle of reference. And remember, tangent is opposite over adjacent. Okay, so opposite over adjacent. So here we go. This is opposite, this is adjacent, and this is the hypotenuse. Okay, label your triangle if it helps you. So opposite would be -2, adjacent would be 5, and we're solving for the hypotenuse. Okay, so Pythagorean theorem. So a squared plus b squared equals c squared. Okay. And then we have negative 2 squared, put it in parentheses, plus 5 squared equals c squared, but we need to solve for c, so that would just be the square root, okay? So negative 2 squared, that's 4, plus 5 squared, that's 25, okay? Or the square root of 29. Oops, sorry, out of frame. Okay, so c, or the hypotenuse, is square root of 29. So this would be square root of 29. Again, you can do this graphically and probably a little bit faster, but you should be able to do it algebraically, especially because it's going to help you with the next example, okay? Or the next topic. So we have everything that we need in that triangle. So now we're going to find cosine. Cosine u. So here we go. Cosine, remember, is co, which is basically adjacent over hypotenuse, okay? Adjacent over hypotenuse. Oops, let me bring it up, sorry. So our adjacent side, if you look, is 5. I'll write it here. 5, and our hypotenuse is square root of 29. So cosine of u is 5 over radical 29. And hopefully you're thinking, she's not going to leave it like that, is she? Because remember, we don't want radicals at the bottom, so we're just going to multiply by radical 29 and radical 29 to the top. And this will simply just simplify to 5 radical 29 over 29. If the coefficient and the denominator can reduce, but in this case they can't. So this is our final answer. 5 radical 29 over 29. Okay. All right, and then we are officially done with example 7. I'm going to have you guys do the checkpoint, but they only gave you one, so I don't think that's enough. So let me give you one more to do on your own, be on top of the checkpoint. Okay, so copy this one down because I think on top of the checkpoint, I'm going to have you guys do one more example, which is this one. Okay. Again, I just don't think they gave you enough. All right, awesome. All right, let's move on to the last example.